Okay, and on to solving logarithmic equations. And again, logarithmic equations is any equation really with a logarithm where the input of the logarithm is some unknown function or expression containing x or an unknown value. So there's a couple different strategies we're going to explore, kind of in parallel with what we just did in exponential equations. So if we only have one logarithm up here, again, isolate it, and then we're going to convert it again using that same definition of a logarithm to the exponential form, and hopefully everything falls out from that. So here, first divide in our example here. First divide by 6. So we'll have log base 2 of 2x minus 3 is equal to 5. Okay, now at this point we can't isolate it any further, so we're going to convert it to the exponential equation. So I have now 2 to the 5th. Again, my output becomes my input is equal to 2x minus 3. Okay, 2 to the 5th is 32. And then, so just doing that arithmetic. And then lastly, solving for x, I'm going to get x is equal to 35 over 2. Okay, and now in our last, when we were solving exponential equations, we did not check our answers. Okay, in logarithmic equations, we actually do need to check our answers, because if we have any, if inside the logarithm it's 0 or negative, that actually returns an undefined value inside the logarithm. Now if I input this one will check, so this one is okay. So we can still say the solution set is 35 over 2. Okay. Again, so that's first strategy. Second strategy is if we have the same base logarithm on each side, we're going to kind of do what we did before with the exponents. It was the same base, so then we just set the exponents equal to each other. Well, with a logarithm we don't necessarily have exponents, but we can still just say that the inputs are equal. So x squared plus 1 is equal to minus 2x plus 4. Okay, and then getting everything on one side and starting to solve this quadratic equation, I have x squared plus 2x, and then I'll have a minus 3 is equal to 0. This factors as x plus 3, and x minus 1 is equal to 0, and if I solve this, x is going to equal minus 3 and positive 1. Okay. Now, again, I should check. So if I put in negative 3, let's see, I square that, that's a positive number. I'm just checking to see if it's positive or negative or 0. If I put in negative 3 in here, that becomes a positive as well. So this one's going to check. And then a 1 in here, that will check. And then this will be a positive number as well. So they both check. So I can say the solution set is bracket minus 3 comma 1 bracket period. Okay, so up until now it's fairly parallel with what we did in exponential equations. Now here we have different bases, or at least multiple logarithms. If we have different bases, we actually have to use the change of base property. Instead here though, I have multiple logarithms. I'm going to get it so that everything is either on one side or use properties as logs. Okay. Now remember, if I have addition of logarithms, that means I can multiply whatever's inside the logarithms, and essentially this is just another way of saying natural log, same thing. So I can write this as 3x minus 2, and then times x minus 1, minus, and I'm going to change this to natural log, of x squared minus 1 is equal to 2x. Natural log of 2x. Okay, and now I have a difference of logarithms, so that corresponds to a quotient. So natural log of 3x minus 2, x minus 1, all over x squared minus 1 equals natural log of 2x. Okay, and now let's see, I can actually just say, well, I have the same logarithms on both sides, so I can drop them and say this is 3x minus 2, x minus 1 over x squared minus 1 is equal to 2x. Okay. Now in order to proceed, I actually need to do, you could cross multiply and everything, but I want to actually do this division first, because remember that this is actually x minus 1, x plus 1. Okay, so I can actually cancel an x minus 1. So I can rewrite this as 3x minus 2 over x plus 1 is equal to 2x. Okay, and continuing with the algebra, now I can cross multiply and I get 3x minus 2 is equal to 2x squared plus 2x. Okay, rearranging, I get 0 is equal to 2x squared minus x plus 2, and this we actually need to solve with the quadratic formula. It can be shown though that the x values we obtain contain imaginary numbers, so this is actually going to have no solution, and that is perfectly valid, so there is no solution to this problem. Okay, so again, the idea is to use those properties of logarithms and combine and condense the expressions as much as possible. Okay, and now before we exit kind of the exponential and logarithmic equations section, I want to look at a couple more challenging problems. So here, this is an exponential equation. It's not completely clear as how to proceed and how to solve this, but as a hint, I want to try a substitution. I want to try saying, let's try y is equal to, not 2 to the x, let's try y is equal to 5 to the 2x. Okay, so this becomes 6y is equal to 7. Now this, if I pull this apart, this is 5 to the 2x quantity squared, because by laws of exponents I can multiply those and get the same thing. So this is really just saying y squared. Okay, and that I know how to work with. That I can write as y squared minus 6y minus 7 is equal to 0. Factor that, y minus 7 and y plus 1 is equal to 0. Okay, so y is going to equal 7 and minus 1. So now, while I substituted, I have to resubstitute. So I'm saying really that 5 to the 2x is equal to 7, or 5 to the 2x is equal to minus 1. Now this one, an exponential equation can never be a negative number. You can try whatever you want. You can even try a negative value in for x and you're still not going to get an answer. So this one, there's no solution to this equation. This one, however, this is one of those where we just need to switch it to logarithmic form and solve for x. So switching to logarithmic form, I get 2x is equal to log base 5 of 7, and then x is just going to equal 1/2 log base 5 of 7. Okay, so, and then I can go through and write the solution set, and this one we'll check too. The solution set is brace 1/2 log base 5 of 7. Okay. Last equation here. Now this one is a log inside of a log inside of a log. Just use the definition repeatedly. So again, base to the output, so 3 to the first is equal to log base 4 of, big bracket, log of 5 of x. Okay. Do it again. 4 to the third is equal to log base 5 of x. And just for reference, that's 64. And lastly, one more step. 5 to the 64 is equal to x. And I would not recommend computing that because your calculator will yell at you. So just write the solution set is 5 to the 64th power. Okay, and that one we'll check. Please don't try it. And that concludes our section on solving exponential and logarithmic equations.